So here's our ear model. I'll go over the structures you need to know for the exam. So remember, the ear is divided into three basic parts. We have the external ear, the middle ear, where you can see the ossicles are, and then the inner ear, which is encased in the temporal bone. So we can remove the petrous part of the temporal bone and see the inner ear. Okay, so we'll start with the external ear. The external ear structure that we can see is the auricle or the pinna, P-I-N-N-A, and that will help funnel the sound waves into our internal auditory meatus, where we have our ceruminous glands that create cerumen, which is earwax. And we can see that we have some cartilage here. This is elastic cartilage. So one of the few places we have elastic cartilage in the body is in the outer ear. As we come into the middle ear, we can see that we have structures, 3 bones, 1, 2, 3 over here, and those are all grouped together called the ossicles. The first ossicle here is the malleus, and it is attached to the tympanic membrane, which is this guy right here. The tympanic membrane, I should say, it separates the external ear from the middle ear. It is also the thing that vibrates in response to sound waves. So the vibrations of the tympanic membrane will vibrate the malleus. The malleus in turn vibrates the incus, which is the next bone here. And then the incus will vibrate the stapes. The stapes then transmits the sound waves into the inner ear. This is an air-filled space, and we have to equalize the pressure between the air pressure in our middle ear as well as the external atmosphere. So this is the tube that helps to do that. This is called the eustachian tube or the auditory tube. And it's collapsed most of the time, but opens up when you swallow or yawn, so to equalize that pressure. All right, and so this leads to your nasopharynx. All right, then we move into the inner ear. The inner ear has this large structure here. So this is all fluid filled. We have the cochlea, we have this middle part, this is the vestibule, and then we have 3 semicircular canals. The anterior one goes up and down, the lateral one lays down to the side, and the posterior. So we have an anterior semicircular canal, lateral semicircular canal, posterior semicircular canal, and these are all responsible for your rotational equilibrium, which is knowledge of what direction you are moving. So it's the rotational equilibrium. And then here is our vestibule. This is responsible for our static equilibrium, so knowing the position of your body and when it's still. And this is our cochlea, so this is our organ of hearing is inside here. So this is a spiral structure. Inside there are 3 ducts, and within one of those ducts is the spiral organ of Corti. Not shown on this structure, but anyways, this is our cochlea where we have hearing, and we can see the nerves extending away. So this one that's directly attached to the cochlea, this is the cochlear branch of the vestibular cochlear nerve. This right here is our vestibular branch, and the vestibular branch breaks off here, but actually should extend all the way to the vestibule. So the vestibular branch and the cochlear branch will come together and extend into the brain as the vestibular cochlear nerve, otherwise known as cranial nerve number 8. Okay, so, a couple more things. On the underside of this guy, you can see a couple of other structures. So the stapes hits the inner ear, the cochlea here, at the structure called the oval window, 13. And then down from the oval window, we have another structure right here. This is our round window. This is where the sound waves or the ripples in the perilymph are dampened. Okay, so oval window, round window on the underside of this structure. Okay, and that completes the ear.